Today we'll learn about factoring sum and difference of cubes. So we've actually done a difference of squares before. Remember, that's of the form a squared minus b squared. It's difference because there's subtraction, and it's squares because each of the terms are perfect squares. Okay. Remember, to factor that, we took the square root of each part and got a and b, and then we put a minus b and a plus b. For a difference of cubes, we are also going to have a pattern that we can follow. Okay, it's a different pattern, but it's a similar idea. It's just another pattern. So if we have a cubed minus b cubed, that will actually factor into a bracket that has an a and a b, and then another bracket that has an a squared term, an ab term, and a b squared term. Okay, and then the signs here are going to be a negative, a positive, and then another positive. That is the pattern that we will be following when we factor difference of cubes. Okay. So let's do some examples here. So for the first one, we have x cubed minus 8. Both of those terms we can take the cubed root of. So if we take the cubed root of this first term, that would be our a value. The cubed root of x cubed is just x. Okay, and if we take the cubed root of the second term, that would give us our b value. The cubed root of 8 is 2. And now that we know what our a and our b are, okay, you don't always have to write them down, I just did here. You're just going to put those a's and those b's into the pattern that we already have up here. So remember, the pattern is a minus b, so in this case x minus 2. And then we have a squared, so x squared, plus a times b, so plus x times 2, so that is 2x, and then plus b squared. Okay. And b squared is, of course, 2 squared, which you can write out as 2 squared, or if you want, you could just automatically skip to the simplified answer and write that out as a 4. And there is our difference of cubes factored. Similarly, for the next one, we're going to do the exact same thing. First, we're going to check to make sure it is a difference of cubes. Okay, so there is subtraction, so it is a difference. And we're going to check to make sure that you can take the cubed root of each term. So if we take the cubed root of that first term, the cubed root of 27x cubed, cubed root of 27 is 3, cubed root of x cubed is x. Okay, and similarly, we're going to take the cubed root of 125y cubed, and that would give us 5y. And now that we know what our a and our b are, we're just going to sub those into this pattern. So take a minute and give that a try, and then unpause the video again to see the answer. Okay, so this would be your first step with everything just subbed in for the a's and the b's. And then we would need to do a little simplification step here. Right, because 3x all squared would really be 9x squared. 3x times 5y would really be 15xy. And then 5y all squared would really be 25y squared. And there it is, fully factored. So that's how you factor a difference of cubes. A sum of cubes is going to be very similar. Okay, it's still, there's two terms. Both terms can be cubed rooted. And it's a sum because there's a plus. Okay, now remember, for sum of squares, you couldn't factor it, but sum of cubes, we can. So to factor this, it's going to have actually the same terms. The only thing that's going to be different is the signs. So for the signs of this, it's going to be plus, minus, plus. And that is the pattern for sum of cubes. So just like before, we're going to try and take the cube root of both terms, and if we can, then we know it's going to be a perfect cube. The cube root of 16 doesn't exist, but if you look, 16 and 54, there's actually a common factor there, and we should always pull out common factors first. There's a common factor of 2. And now we do have two terms that can be cube rooted. So if we took the cube root of this first term, 8x cubed, that would be a 2 and an x. And if we took the cube root of the second term there, we would get 3y. Okay, so the 2 is just going to stay on the outside. It's going to hang around all the way down. And then we're going to use the pattern to factor that sum of cubes. So it's 2x plus 3y times 2x squared minus 2x times 3y plus 3y squared. Okay, so that's just subbing it in, following the pattern of the a's and the b's. And then we do want to simplify this and make sure that there's nothing else that we could factor. So simplifying 2x all squared, that would give us 4x squared. Okay, multiplying the 2x and the 3y, that'll give us negative 6xy. And then last but not least, we'd have a 9y squared. Okay, and there's no more common factors in any of those brackets. There's nothing that we could factor any further, so we'd be done there. Okay, so for the next one here, we'll find the a's and the b's, and then I want you guys to pause the video and give it a try yourselves. So for the a, if we take the cubed root of 64x cubed, we would get 4x. And then if we take the cube root of 125, we get a 5. If we take the cubed root of y cubed, we get a y. And if we take the cube root of z to the power of 6, we get z squared. Okay? And if you think about why it's a z squared, it's because z squared cubed is z to the 6, which is what we really want there. Okay, so when you actually cube root variables with exponents, you're really just dividing the exponents by 3. And that would get you your answer. So take a minute, give this one a try. Okay, so you'll notice that we took each of those a's and b's, we put it in wherever there was an a and b in the formula, and then we simplified it. And you need to make sure when you're plugging the a and the b in, put it in brackets, because that squared applies to the entire 4x. Right, you need to make sure to square the 4 and square the x. And similar down here, the squared on this last term applies to all 3 parts of that term. So we squared the 5 to get 25, we squared the y to get y squared, and then we squared the z squared to get z to the 4. And we multiplied those exponents, the 2 and the 2, to get the 4. So you might be asking yourselves, how do I remember these patterns? Okay, and there is a little trick to remembering them. So the trick here is SOAP. So the S here stands for same, the O stands for opposite, the A stands for always, and the P stands for positive. So same, opposite, always, positive. So if we look at the 2 formulas here up at the top for sum and difference of cubes, for the difference, we have a negative. So if we follow same, opposite, always, positive, the same sign would mean a negative, opposite sign would be a positive, and the last one is always positive. Similarly, here, if it is a sum, then same sign is how we start, so plus, opposite sign, minus, last one, always positive. Okay, so that doesn't help you with the actual A's and B's, but it does help you remember the order of the signs. Okay, and the A's and the B's are the same for each of the formulas. So here's a couple more complicated examples, but same thing, we have a subtraction, so it's going to be a difference, and you can take the cubed root of both terms, so it's a difference of cubes. So the first thing we want to do is determine what our A and our B is. So if we take the cubed root of this first term here, whenever it's just a bracket cubed, the cubed root is just that bracket. So it would be x plus 2. And then the cubed root of 27y cubed would just be 3y. Once you have the A and the B, it becomes exactly like all the other examples. We do A minus B, okay, and then we have an A squared, then we have an A times B, and then we have a B squared term. And remember SOAP, because this is a minus, same sign, opposite sign, always positive. And then it's a matter of simplifying this and cleaning stuff up a little bit. So here we have an x, we have a minus 3y, and we have a 2. Okay, and those brackets didn't actually do anything there because there's nothing out front of them. For the next one here, we have x plus 2 all squared. So you do have to expand that, because remember, x plus 2 all squared is really like x plus 2 times x plus 2. So you either have to FOIL it out, or you have to use the shortcut. And the shortcut is square the first term, first times last times 2, so x times 2 times 2, square the last term. And then you just keep going. This 3y, you would need to multiply it in. So you end up with 3xy plus 6y. And then simplifying the very last term there, we would get 9y squared. Okay. And if there are any like terms, we would want to combine them. And in this case, I don't think there are. Okay. And sometimes you will see it rewritten so that it's in decreasing power, but that's less of a big deal. So I will put all the degree 2 terms first, so x squared plus 3xy plus 9y squared, and then I'll put all the degree 1 terms, so that would be the 4x and the 6y, and then I'll put the constant at the end, which is usually how we'll see it written. Okay, so there we have our factored expression. Okay, so take a minute, give the next one a try, and then when you unpause the video, you'll see the solution. So your A and your B were really just what was in each of the brackets, because when you cube root those brackets, you just end up with the inside of the brackets. Okay, so we subbed that in to our pattern for the sum of cubes. And you want to make sure here that you are putting all the A's and the B's in brackets, because there are multiple terms, and you do need to expand all of those brackets. So in the first one there, I just grouped like terms, added that -1 and that 3. Okay, and in the next one, you had to expand that 3x minus 1 squared. You had to FOIL out these 2 terms that were multiplied together. Okay, make sure, because it's a subtraction, after you're done FOILing, you still need to multiply that negative into each term. Okay, so you do need to be careful there. And then for the last term, we just once again had to expand that bracket squared. And then collecting like terms got us to this final answer. So I want you guys to give this next one a try. You're going to do one of the methods, and then in the next video, you can watch and see how there's 2 different ways to do the question.